Hi, today's lesson is lesson 9.2. We're going to be talking about reflections. So far, we've talked about the type of transformation that was a translation, which was a slide, but now we're going to be going into a reflection. So let's talk about that. Okay, so our standards are I can define a reflection, I can understand properties of reflections, and I can graph reflections. And we're still in the same standards from the last one, G1 and G3, that stands for geometry. So we're going to be able to understand that lines are taken to lines and line segments to line segments, angles are taken to angles, parallel lines are taken to parallel lines when we are doing properties of rotations, reflections, and translations. And then G3, we're going to be able to describe the effects of the dilations, the translations, the rotations, and the reflections on two-dimensional figures using the coordinate, and that should say plane. So I'm going to minimize myself. So let's talk a little bit about reflections. So a transformation is a function that describes a change of a figure in position, size, shape, and now we're going to add orientation. Remember, the translation didn't change the orientation, it was a slide. So the input is called the preimage and the output is called the image. So a reflection at the bottom of the screen there is a transformation in position and orientation. So here is a picture of a reflection. The preimage is on the right and the image is on the left. Get my little spotlight here. So a reflection is a transformation that flips a line across, a figure across a line. So here is a line. This is the preimage, and we're flipping it over to the other side. The line is called the line of reflection. This happens to be the line of reflection right here. That is the y-axis. Your line of reflection could be the y-axis. It could be the x-axis. It could be any other line that you can draw on a coordinate graph. So it just depends on what the problem is asking you to do. Each point and its image are the same distance from the line of reflection. So if you look at this point right here, that's 1 unit to y-axis, the line of reflection. The image over here, that same point is 1 unit from the y-axis as well, the line of reflection. So now I'm going to go under the document camera and I'm going to show you some things. I wish I looked like that, but I kind of tried to find somebody that looked like me a little bit. Okay, so let me pause it for a minute and I'll be back under the document camera. Okay, so this is our pre-image, triangle ABC. And what we want to do is do a reflection across the x-axis. So this is x, and then up here is y. So to go across the x-axis, we're going to take it, we'll go this way, we're going to take it and we're going to flip it. Okay, we're going to take it where it is and flip it. It should end up the same, each point should be the same distance from the x-axis as it was on the top, but just on the bottom now. So one way of showing how that's going to work out is to take this and we can fold it right along the x-axis like that. And we can see that it should appear somewhere over here. So I'm actually going to do the reflection, and how you do it is you take each point. So point A is how many units from the x-axis? Well, it's 1, 2, 3, 4, 5 units. So I have to go 5 units below the x-axis for the reflection. 1, 2, 3, 4, 5. Okay, that will become our point C. It's going to go backwards now. We'll label that in a minute. And then C is 2 units, so we're going to go 2 units. 1, 2. B is 2 units, so B is going to be 2 units as well. And then we're going to connect the dots. Actually, I should use a different color so that you can tell that it's a reflection, even though you can because of the labeling too, but let's just do that. Make it pink. Okay, there's my reflection. Now, which point is A, which point is B, and which point is C? Well, this is A prime, this is C prime, and this is B prime. And you can see how if I fold it right on the x-axis, that is exactly where my shape will end up. It'll take it and it'll flip it. Notice how CB is still the same length, AB is still the same length, and AC is still the same length. So the shape has not changed, the size has not changed, only the position has changed and the orientation. What happens if I reflect it across the y-axis? Here's y, right? So we would do the same thing. We would fold it. Try to fold it right on the line here. And it would end up somewhere over here. So let's do that. So A's point is 1, 2 units from the y-axis. So 1, 2 more units from the y-axis over here. C is 2 units. So 2 units the other way. And B is how many units from the y-axis? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay. This would be B prime. This would be C prime. And this would be A prime. And we'll make it double prime because it's a different reflection from the first one. And then I should change colors, so I'll make this one green. How fun is that? Here we are. That is a reflection across the y-axis. This is a reflection across the x-axis. So now let's talk about that a little bit. So the distance from point A to the x-axis is how much? Let's write this down. Let's put it up here. The distance from point A, I don't know if you can see that. The distance from A is 1, 2, 3, 4, 5. From A to x-axis is equal to 5. Okay, what's the distance from A prime to the x-axis? A prime, doesn't matter if it's below it, what's the distance? 1, 2, 3, 4, 5. So the distance from A prime to x-axis is equal to 5. 5 units. You can do that with B as well. The distance from B to x-axis, where's B? 1, 2. What's B prime to the x-axis? 1, 2. And the distance from B prime to x-axis equals 2. And if we were to do that for C, you can see that it's also 2 units either direction, right? So that's the property of a reflection, that each point on the triangle when you reflect it has to be the same distance from the line you reflected on as the original image. So we were to go this way, the distance from A to A double prime, from to the y-axis, sorry, I'm ahead of myself, is equal to, from A to the y-axis, 1, 2 is 2 units. The distance from A prime, double prime to the y-axis, A double prime, 1, 2, 2 units. Doesn't matter if it's on the other side, just count the units. Let's do C. The distance from C to y-axis, how many units? 2. And the distance from C double prime to y-axis equals 1, 2. Also 2. Okay? So a reflection has the same distance from the line of reflection as the image. So the image, the pre-image and the image have the same distance. Okay, so now I'm going to go back onto the camera. Hang on a sec. Okay, let's talk a little bit about the properties of reflections. So reflections maintain the same length of their corresponding sides. Reflections maintain the same measures of their corresponding angles. The sides that were parallel in the pre-image remain parallel in the image. Reflections preserve the size and shape of a figure. Our triangle didn't change shapes, didn't change size, but its orientation changes in the mirror image to the mirror image of the original figure. And a reflection produces a figure that is congruent to the original figure. And again, congruent at the bottom means figures that have the same size and the same shape. Okay, we'll do another demonstration. Okay, here we have trapezoid, T-R-A-P, trap. And we want to reflect it across the y-axis. So we're going to prove the properties of a reflection. So we want to flip it from here to there. So that would be the y-axis. Let's put y there so we remember. And then this is x, so we remember. Okay, so what we do is we take each point, let's make a different color here again, and it has to be the same distance on the other side of y. So A is 1, 2 points, so A has to be 1, 2 on this, right? And then it'll be A prime. R has to be the same thing, 1, 2, 1, 2. So R prime. And P has to be the same thing. We have to go 1, 2, 3, 4. So we have to go 1, 2, 3, 4. P prime, and then T. 1, 2, 3, 4. So 1, 2, 3, 4. T prime. And then we connect our dots. Oh, that's a real wide dot. I mean a wide marker here. Try to use the skinny end. There we go. So there is the image, the pre-image and the image. It's reflected across the y-axis. If I notice the lengths of my sides, let's use centimeters here. From here to here is about 2 centimeters. I don't know if you can see that on the camera. And then over here, it's 2 centimeters, right? This is about 3.5 centimeters. This is 3.5 centimeters. I have not changed the size of my trapezoid with the reflection. All I've done is flip it. I've changed the orientation because I flipped it. That's mirror image, and I've changed the position. The angles are all the same size. I don't have a protractor on me, but if I did, this angle would be the same as this angle. This angle would be the same as this angle. Usually you put a little mark in there to show which angles are the same. 2 marks go in that one. R is the same here and there. I would get 3 little tick marks. And A is the same angle as the other A. Okay, so all the angles are still the same. That means the size hasn't changed, right? If it did, if the angles changed, then the shape would have been become distorted, right? So the only thing that has changed is the orientation and the position. Okay, let's see if there's anything else I wanted to show you from that example. Nope. Oh, one more thing, the parallel. That the sides that were parallel before, T, P, and RA, are parallel after. T prime, P prime, and R prime, A prime. Okay, graphing reflections. To reflect a figure in the coordinate plane, reflect each of its vertices the same number of units on the opposite side from the line of reflection. Then connect the dots. And that's what I just showed you under the document camera. A corner where edges meet is considered a vertex. So plural is vertices. Okay, you're going to get a chance to try some of these reflections. See you back in a moment. Okay, welcome back. I think that was my last demonstration. I don't think I have another one. Do I? No. That was my demonstration. Okay, I lied. I did have one more example for you. This is example 1 from your book. And you'll notice I have triangle XYZ, and the book says to do a reflection across the x-axis. Which one's the x-axis? That one, right? And this is Y. So we're going to go from here to there. How do I do it? I take each vertice, make it the same distance from the x-axis as it is on the bottom, do the same on the top. So let's take point Y. It's 1 unit from the from the x-axis. So 1 unit from the x-axis on top. I'm going to put it right here. And then I have to move the x 1, 2, 3 units. 1, 2, 3. That's x prime. And then z is 1, 2, 3, 4, 5 units to the x-axis. So 5 up. 1, 2, 3, 4, 5. Z prime. And then I connect my dots. And that is a reflection. It's a mirror image, but we just flipped it. Okay. And notice that it's the same shape, the same size, the orientation and the position have changed. Okay. So hold on to your hats. We're going to do a little higher order thinking here. And this is stuff you're going to get into more when you get into high school. But I wanted you to think about it a little bit. So we reflected over the x-axis and the y-axis, right? Those were straight lines, either horizontal or vertical. How can you reflect an image across a diagonal line of a reflection? Can you do that? Is there such a thing? Remember I told you you could draw a line anywhere on your graph and you could reflect it across that line. So here I have a triangle. Ignore these little points that was on the picture that I downloaded. So you have this triangle here and we are going to reflect it. Waiting for it to pop up here. Across the y equals x line. So you're going to say, well, what the heck is the y equals x line, right? Well, the y equals x line is just plug in some points. If you plug in, let's say, for example, let's grab a number here. So y equals x, right? So if I plug in 0.1 for x, what does y equal? Has to equal 1, right? So that's 0.1 comma 1. What if I plug in a 2 for x? If I plug in a 2 for x, I then get 2. What's the only number that y could be? 2. So 2 comma 2. What if I plug in a negative number? What if I plug in negative 2? Y would have to be negative 2. So the y equals x line is just 1, 1, 2, 2, 3, 3, 4, 4, negative 1, negative 2, or negative 1, negative 1, negative 2, negative 2, negative 3, etc. So first we're going to graph that. So there's the points, some points, 0, 0, 1, 1, 2, 2, negative 1, negative 1, negative 2, etc., etc. Plug some points in, and you'll get a line that looks like this. That is the y equals x line. A lot of times you will find shapes being reflected over this line, especially when you get into higher math next year. So now here's the key. With a reflection over y equals x, the x and y coordinate points just change places. That's all that happens. You just have to change places. So you have point A was negative 4, negative 2, it says right here. So just A prime is going to be switched. It's going to become negative 2 first and then negative 4. So let's see, where would that go? Negative 2, let me grab my spotlight. Negative 2, negative 4. Oh, negative 2, negative 4. It's going to be right here, right? See where my dot is? There it is. Negative 2, negative 4. And then we have point B was negative 2, 0, even though you can't see because the line's crossed over it. B prime, it's going to be, just flip the negative 2 and the 0. 0, negative 2. So where's that? 0, negative 2. It should be right there. And there it is. So that's point 0, negative 2. And then point C, it was negative 5, 1. C prime is going to be, just switch the numbers, 1, negative 5. So that's 1. Go down to -5 right here. So that's your C prime. 1, -5, and then you connect your dots. There we go. So that is a reflection across the y equals x axis. So you can do diagonal reflections. Just remember the key points of how to do that. Let's take a look at one more. Okay, same shape, but this time, put our points in there. This time, let's reflect it over the negative y equals -x. How do you do that? Well, you just plug in a number for x again. If we plugged in 1, there's a negative sign in front of that now. So the y would have to be -1. I mean, if we plugged in 1. Yeah, if we plugged in, so that point would be 1, comma, -1. Because the minus sign is there. So if I'm just plugging in a 1, it becomes -1. But I really plugged in a 1, okay? So don't get confused by that. And then if I plug in a 2 here, let's write it on there. So now I've plugged in 2. What's y got to be? Well, the opposite, -2, right? -2. If I plug in 3, I put 3 here. Now I've got 3 plugged in for x, and y has to be -3. What if I plug in a negative number, though? Let's say I'm going to change colors here. Let's say I plug in -1. -1. Well, I have a negative sign in front of it already, so 2 negatives are going to make a positive. So I plugged in -1, but my result, my y value, is going to be +1. If I plug in -2, my result is going to be +2. So those are some points on the y equals -x line. Let's clear those because I'm going to pop those up here for you. So the graph points would be 0, 0, 1, -1, 2, -2, 3, -3, 4, -4, 5, -5, or the other way, -1, 1, -2, 2, -3, 3, etc. So let's graph that line. That's just a line going downhill, right? Just like the y equals x line, it's just the opposite. It's the y equals -x line. So now we want to reflect that across the y equals -x line. So when you reflect over y equals -x, which you'll be doing a lot probably next year, you change places with the numbers in the points, and you change the signs. So you have to do 2 things. So you do the same as you did in the previous one, change the numbers around, flip them around, but then you also change the signs. So point A was -4, -2. Let me get my spotlight here. And A prime now is going to be, flip them around, 2, 4. So you flip the 2 first, the 4 next, and then they were negative, so they become positive. So where's 2, 4? 2, 4 is right there. So that should be A prime. Now point B is now -2, 0. B prime is going to be, you're going to make the 0 first, make the -2 second, and change the signs. Well, 0 doesn't change signs, but the -2 would become a, +2. So point B would go from -2, 0 to B prime of 0, +2. So 0, +2 is right here. And that's 0, +2. And then finally, point C here was -5, 1. Flip it, -1 would come first, and then 5 would be second, but change the opposite sign. So it was 1, so now it's -1, and it was -5, so now it's +5. So -1, +5 is right here. And that's point C prime. Connect your dots. And you have your reflected triangle over the y equals -x axis. Okay. All right, you get to try some of these types of problems. See you back in a moment. Hopefully that went well for you. Your homework is on Google Classroom, and I will see you next time. Goodbye.